Okay, so it says write each problem using what's called exponential form.
Yeah.
Exponential form is a base to an exponent. The base is always the number that's there, that's already there. So this is going to be 6 to the power of, or the exponent of, and you just count the
3.
number of 6 to the 3. The next one would be 8 to what power? How many 8s do you have here?
2. So
2.
8 to the second power.
Yes. Yes. And then the next two questions are kind of going backwards. It's saying write them in this what's called expanded form. Okay. So the first one means that there are 4. You start with the exponent, 4 4s, 4 4s, which is a little weird, but it's 4 times 4 times 4 times 4. Okay. It just so happens that the base matches.
Yeah.
Okay. But the next one means that there are 4 6s, and that's when we're actually
6 times 6 times 6 times 6.
Yes. And if this were a test or a quiz, I would recommend counting them just to double check here. No reason to miss that. This is 4 4s. All right. Have you done any of the rearranging problems on the ordering integers on the next page?
No, I haven't.
Okay. All right. Well, let's take a look at a couple of these problems here. So let me snip this in and we'll look at it together here. All right, so it says to rearrange each set of numbers below in order from smallest to biggest, least to greatest. They're using different words, but they mean the same thing. Right. So you can see here minus 15 is smaller than minus 12, smaller than 0.
Yeah, so then that would be negative 30, negative 18, 0, 10.
Perfect. Okay, so I just want you to do the next 2 for me, and then we'll move on to something else. But if you could just, I just want to confirm that you feel like you've got this down before we move on to some other ones. And there is 1 or 2 at the end I want us to look at. Let me know when you have your answers for 3 and 4, please.
All right. All right. The answer would be, for number 3 would be negative 8, negative 1, 1, 8.
Good.
And the other one would be negative 50, negative 45, negative 25, negative 20.
Good. Okay, so the only one I want us to look at together is the last one, number 10 here. I think the rest you'll be able to do pretty quickly.
Yeah.
But it's the only, I would like you to try this on your own and just see if there's any issues here. Just number 10, please. And then we'll go back and we'll do some long division problems, because I know that's where there's been a bit of a struggle.
All right, so for this one, I'm guessing it is because I don't really know if this is right or not.
Okay.
But so negative 1/2 or
okay, yeah, so let me draw. So this is what I was trying to avoid, because this takes time to do. Here's a number line. Here's 0, here's 1, and here's -1. Okay.
Yeah.
All right. So we obviously know that we're those 3.
1.5.
Well, it's so you gotta be careful with the way you said that, and because the way you said that was -1.5. This is -1 half. There's no and.
-1/2. Oh, okay.
And it's a small distinction. I'm not trying to be critical of you, and please don't take it that way. It's that this is 1/2 or half, but with a negative in front.
Oh,
And this is actually a number between 0 and -1. That's where -1/2 lies.
there we go. So.
Okay, so in this case, it's -1, -1/2, 0, and 1.
Yeah.
So just really quick here, when you get that down here, I want to just clarify some things here with you. Let me know when you're ready. I want to make sure you've got this down.
Okay. Ready?
Okay, so this first number here is 1 and 1/2.
And
1 and 1/2. The next number is
One half.
just 1/2. And there's times in math when the language matters, and this is one of them. Okay, so similarly, if we go like this, this is -1/2. And if I write this other number, it is negative
1 and 1/2.
1 and 1/2. Okay. So just be aware of the distinction between them. Okay, let's go to number 2. I feel like you could probably do number 1 on your own. Let's go back to number 2 with the quotient and check. So just let me know when you're ready, and we'll look at this problem together here.
Okay.
So we've done this for a couple of lessons. I think you understand how to do it, and there's really no substitute for practice, at this point. But a few reminders here. I like to make a table off to the right. It's not necessarily like a traditional table, but just some numbers, operations. So we've got 27 times 1, that's 27. 27 times 2. If you don't know that right off the top of your head, it's 7 doubled, which is 14. 20 doubled, which is 40. 40 plus 14 is 54. And that is a good way to try to work through this. 27 times 3, you have a choice. You can either multiply or you can keep adding 27. Right. And I think your preference has been to add, but I do want you to try to move towards multiplying. Okay. So 3 times 7 is 21. 3 times 20 is 60. When you add those together, you get 81.
That's too much. It'd be the 27 times 2, 54.
Yeah, and one of the things I want to emphasize again with you is I like to get the two numbers that surround it. I don't like to just assume that it is between the 2 and the next number. I'd like to actually get it. Plus, we may need it the next time we do the calculation here. So 2 in the tens position, 2 times 27 is 54. Subtract, and now you get 129. And that's a good reason for us to have done this, because now we've got to keep going. 27 times 4. So again, the way I look at this is the way I want you to do it. 4 times 7 is 28. 4 times 20 is 80. You can add those together and get 108. So I want you to find 27 times 5, please.
Okay. $135.
Yes, exactly. So we know for sure that it's between 4 and 5. So we'll put a 4 here. 4 times 27 is 108. You subtract and get 21. So remainder of 21.
And then we check.
Yep. And I'm going to use this region. I'm going to use this space in the middle to check. You might even want to denote that. So you're going to take 24 and multiply it by 27. All right, and to do this, this is your basic math facts, like 1-digit times 1-digit multiplication. So
Mhm.
if you have some time each day, I'd recommend practicing that. I'll mention that to your mom as well. But go ahead and work this out for me, please. And we're going to take that number and add the 21 to it.
Okay.
I'm just going to start working it out. It's up to you if you want to work, look at my
Okay, I'm
screen or
almost
not.
done. I'm at adding what I had, like what I got from the multiplication, like
Good.
adding. So I'm almost done. Okay.
Okay, did you come up with 648 and then you're going to add 21 to it?
Yep.
Perfect.
All right.
All right, let me know when you get all that down and we'll move on to another question.
I have it all down.
Excellent. Okay, so let's do number 4. Very similar. All right, and you'll find that the problems we've been doing are going to be done exactly the same way. 69 doesn't go into 8, but it does go into 86. But we need to know, is it 1 time? Is it 2 times? And that's
I know. So
so
I'm
let's
guessing it's gonna be 2 times, just as a guess,
okay.
because 6 plus 6 is 12.
Okay, well, what I recommend, and this is going to always work. What we're doing on the right here is making this table, building these rows up.
Yeah.
So we're gonna double 69. So there's a couple ways to do that. The way we've been doing it, 2 times 9. Can you tell me what 2 times 9 is, August?
18.
18. And then 2 times 60 is
120.
120. And so when you add those together, that's
38.
138. And notice I didn't actually like complete the operation over here. You don't, this is like scratch work off to the side. I mean, it's still part of your problem, but you don't have to work it all out completely. So we know that 69 goes into 86 somewhere between 1 and 2. So we're going to put a 1 in that position. Is that clear? Is that
Yeah.
okay? Great. 1 times 69 is 69. And we're going to subtract. And I mean, when I looked at some of your work, I know there's some issues with this. You're really just looking at, I'm going to emphasize this here. You're just looking at this part. You're not at all concerned about the 2 and the 1. So it's 86 minus 69. Sometimes it's easier to like ask yourself, what would I add to 69 to get to 86 rather than subtract? But that's your call in terms of what you want to do there. So I bring the 2 down.
And okay.
So now we have the same problem as before. It's like, well, we know it goes in more than once, more than twice, but we need to figure out what it's bounded between. We need the lower and then the upper bound. So again, you got to multiply. You can add, I want you to multiply that. What is 3 times 9?
27.
27. And what is 3 times 6? August, are you with me?
Oh, 18.
18, but then you put another 0 there because it's really 60. And then you don't have to add it up. It's 207.
Yeah.
And we're happy. We're like, okay, 172 is between 138 and 207.
And put the 2.
Put the 2 there. 2 times 69 is 138. Subtract again. You can borrow if you want. I tend to add, like I say, okay, I can get to 140 by adding 2 to this, and then 72 is another 32, so it's 34. It's okay if you're, grabbing from there and borrowing and stuff like that. Totally works. You get the same answer.
Mm-hmm.
Okay, so let me know when you're at this point on the
I
problem.
am.
Okay, so 341 is pretty far away from 207. And this is where you kind of want to guess, like, I'm going to just guess 5 because for now, because I don't want to try all of them if I don't have to. So 69 times 5, what is 5 times 9? Can you tell me that?
63.
5 times 9, just 5 times
Oh,
9.
5 times 9.
Yes.
54.
45.
45, sorry.
Okay. 5 times 6 is 30. And then I'm going to put another 0 there. So it's 300. So 345. So the good news is I'm bigger than it. But bad news is I do have to calculate 69 times 4. So I'd like you to do that for me. Calculate
Okay,
69.
69 times 4. Okay.
Yes. Do you have an answer for me?
I got 3. What did I get again? 69 times 4. I did. Wait, what? No, that can't be right.
It sounds like you're using a calculator. Is that possible? Or are you trying to do this by
No,
hand?
I'm doing it on paper, but
Okay.
I got 370. I know that's
Okay.
not right.
So that's too large. What is 4 times 9?
4 times 9 is 36.
36. I wrote that up here. What is 4 times 6?
24.
So you add a 0 because it's really 60,
Mhm,
and then it's 276.
okay.
All right. So we know that it goes in because 341 is between 276 and 345. We know that we're going to use the smaller number 4. 4 times 69 is 276, and we're going to subtract. All right. So I know they teach you to borrow, and we can do that, but I also want to show you that, like, if you take 276 and you wanted to get it to 300, you would add 24. Do you see that? Do you see how 24
Yeah.
plus would get you there? And if you want to get to 341 from 300, you would add 41. Now, why do I do this? Because adding for us is way easier than subtracting. Just a fact of life. Okay. So if you want us to do more kind of traditional borrowing, we can do that. But let's there. So let me know when you get all this down. I do want to do some problems on the last page. And if we have time, we can come back to some of the others. We did not check this. I want to move on to the last page to make sure we get coverage on everything, but you'll want to check this on your own here. So can I move on to the last page, August?
Sure.
Okay. So I'm looking at the last page and the instructions say, well, there actually are no instructions. It should say to simplify or reduce. Do you remember what these vertical bars mean? Do you remember the words that go along with that from class?
No.
It's written right above the word instructions.
Absolute value.
Absolute value. Yeah. Now the thing with absolute value that's really cool is that it always returns a positive number. Okay, so if you input a negative number, you said this is a negative 12 inside the absolute value.
Yeah.
It always returns a
And
positive
that would be
number.
12. And then if you were doing a positive 12, it would also be 12.
That's right. So what is the next number here for number 2? What would
Negative
that be?
97. The answer to that would be 97.
Okay, so the way this is written is, and I'll do that for number 3 is you would read it as absolute value of -4. -4. Okay, so what number would go here?
Would be a 41.
I think it's, so this isn't written well. I think it's absolute value of -4. So it's just
Oh.
-4.
Oh, okay. That'd be 4.
Good. Okay, so the ones that we definitely need to talk about here are 4 and 5, 6, 7, and 8, and maybe 9. So notice number 4 says absolute value 2 plus 2. Okay, now what is,
No, that would
so,
be 4.
It is 4, but here's why, because this is what matters. There's actually what are called implied parentheses inside the absolute value. There's actually parentheses in here. And that means you have to do this first, whatever is inside here first, before you take an absolute value. So you add up the numbers and then you take the absolute value of 4. So in terms of like showing your work, you may want to put the absolute value of 4 here and then write 4 as your final answer.
Okay.
So for example, number 8, you want to first add 5 and 3, which happens to be 8.
Mm-hmm.
And then you take the absolute value of 8.
Should be 8.
Yes. Okay, so let me just go off to the side here because this does matter. Let's say it was the absolute value of 4 minus 7.
Minus 7, you would do, the answer to that would be,
What is 4 minus 7? Let's start with that.
3.
It is -3.
-3, sorry.
And then you take the absolute value of that, which is
3.
3. Okay, but you have to do the operation inside there first. That's the point. Okay, we've got just a tiny bit of time left. Do you want us to go back and do a problem like 1 or 3 or 5, or do you want us to do some more absolute value? What do you want to do for the last 2-3 minutes of our lesson?
What was the first option again?
Just more of the long division problems.
No, I guess. I guess we get these more absolute values.
Okay, so let's finish up the rest of this page here. What is the absolute value of -9?
9.
9. And the one on the right here is the absolute value of 11.
11.
Good.
3.
3. Good. And then let me snip in the rest of these on this page.
Right now I'm at 13.
Excellent. So what I'm going to do here is I'm going to write the answers down, but I'm going to ask you to not look until you're done. My screen just glitched. There we go.
Okay. So I'm at 100. It's 100. All right, done.
Okay, so do you have any differences from what I have here?
Nope.
Oh, perfect. Okay, is your mom or dad available to give them some feedback on today's lesson?
No, because they're at a meeting right now.
Okay,
I'm at my grandma's house.
all right, cool. Well, I will let your mom know that we can that I'll give her some feedback. Here's all I'm going to tell her is that I want you to work on your multiplication. Not this, but what I really need you to be fast at, and this is just so you can do math faster in your class. Like when I ask you 4 times 8, I need the answer that fast. Like without even thinking about it. I need you to be
Okay.
like, boom, boom, boom. And I don't expect that today, tomorrow, this next week, but like in some amount of time, I really want you to be fast at that
Okay.
because it will help you. It's gonna, you'll impress your friends, with how quickly you're able to do it. So I'll just mention that to your mom or dad if I get to talk to them. So thank you
Okay.
so much. I hope this helped, and I'll see you next time.
All right.
Have a great night. Bye now.
Bye.